Hello students, welcome back to our channel Diksha Karnataka. So mock test 6th has been released, right? So I hope all of you have downloaded the question paper and attempted it under exam conditions. So in this video, I'll be discussing the first part of chemistry solutions, that is from question number 1 to question number 30. So if you haven't downloaded the question paper, you will get the question paper link in our WhatsApp channel. Okay, so the link of the WhatsApp channel will be there in the description section. So please join the WhatsApp channel and you can also get the solutions of all other mock tests in this channel. Okay, so let us start. I hope everybody has done it. So we'll be checking all the questions. I'll be telling you the right approach and what mistakes could have been done in these questions. Okay, so starting with the first question. So this question, if one atom of an element A weighs this much, okay, so 6.644 into 10 to the power of minus 23 gram, then the number of gram atom in 20 kg of it is, okay. Now what is gram atom? Gram atom is nothing but moles, okay, that is the first thing we should know. This question is from the basic concepts of chemistry. Now we should know that mass of one atom is given, and if we find the molar mass, then how to find? 1 mole contains Avogadro number of particles, right? So if I write mass of one atom, according to question, this value is 6.644 into 10 to the power of minus 23 gram. Now if I want to calculate mass of 1 mole of atoms, that is nothing but my molar mass, right? Now mass of 1 mole contains Avogadro number of atoms, so I can tell mass of 1 mole of atoms of element A, okay, we are talking about this particular element A, then that will be nothing but 6.644 into 10 to the power of minus 23 gram, which is the mass of one atom into the Avogadro number into 10 to the power of 23. Okay, so if you solve this, you can see it will be coming around 40 grams, 40, right? 40 grams. So mass of 1 mole of atoms of element A is 40 gram, which is nothing but your molar mass. Now given mass is to you 20 kg, molar mass is known, then can't we find the number of moles? Very simple now. Number of moles is nothing but given mass by molar mass. Given mass is 20 kg, okay, and we have molar mass that is 40, okay. So we can solve this one. So I'll get 1 by 2 into 10 to the power of 3, that is 0.5 into 10 to the power of 3, that is 500, right? So the correct answer for this question is option A. So what are the tricks here, or what are the points you should know? First is what is gram atom. Okay, gram atom is nothing but moles. Then how to get the molecular mass. How I can get the molecular mass if I know the mass of one atom. Okay, so multiply it with Avogadro number, you will get the molecular mass, then use the formula for number of moles. Okay, so now let us see the next question. We have the uncertainty in the momentum of an electron is given and find the uncertainty in the position. So we have this formula, delta x into delta p is equal to h by 4 pi, right? Now let us calculate delta x value will be equal to h by 4 pi into delta p. So let us substitute all the values here. 6.63 into 10 to the power of minus 34 divided by 4 into 3.14. Delta p value is 10 to the power of minus 5. So if you solve this value, the answer will be somewhere around 5.27 into 10 to the power of minus 30. Okay. So here I'll be telling you that calculation is little lengthy, but certain questions will have calculations. So we have to give time to certain questions for calculation. The correct answer for this question will be 5.27 into 10 to the power of minus 30. Okay. Next question. The order of first ionization energies of the elements lithium, beryllium, boron and sodium. So first of all, imagine where these elements are present in the periodic table. So if you see, we have lithium, then we have beryllium, then we have boron, and here we have sodium, right? So ionization energy decreases down the group and increases along a period. So definitely sodium ionization energy will be the least. So I can write sodium will be least, right? So we can eliminate this option. Okay, please keep on eliminating the options. Now you know along a period the ionization enthalpy increases. So my expected answer can be boron, beryllium and lithium. Okay, now you see, very fortunately I'll tell that option is not there. Okay, actually if you see the electronic configuration, lithium is 1s1, beryllium is 1s2, boron is 1s2 and 2s1, right? So if you see, beryllium has fully filled electronic configuration. So to remove one electron from beryllium, we will require more energy. Here, even though size factor is there, but the stable electronic configuration is more dominant. So that is why what happens in the configuration, we get beryllium coming first, then boron, and then lithium, and then sodium. Okay, so this is because of fully filled electronic configuration of beryllium. So the correct answer for this question will be option B. So periodic trends, okay, all the exceptions, please remember those exceptions and do many more questions from this chapter. It is very scoring topic. Only thing you have to little focus on the exceptions. Okay, next, hybridization of xenon in XeF2. So there are many formulas to calculate hybridization, but how we solve is, xenon has 8 valence electron, right? And now there are two fluorines will form bond. So I can write 2 electrons will be used up. So how many we have lone pairs? 3 lone pairs and 2 bond pairs. So the structure we can draw like this. This is 2 bond pairs and we have 3 lone pairs. So while calculating the hybridization, you have to consider lone pairs plus bond pairs. So we have 2 bond pairs and 3 lone pairs. So that is your 5, right? So the hybridization for this steric number 5 is sp3d. So the correct answer for this question will be option number C. And the geometry will be linear. So we got one question from this chemical bonding. So Vesper theory is very, very important. Practice all the geometries, their examples and the hybridization thoroughly. Okay, next question. H2O is dipolar whereas BeF2 is not. It is because. So for this you should know the structure of both the compounds. H2O is having a bent molecule. So the dipole moment is not cancelled. Okay, so that is why it is non-polar. Whereas if you see the shape of BeF2, it is a linear molecule. Okay, so the dipole moments are opposite in directions and they cancel each other. So the net dipole moment is 0, as a result of which the molecule is non-polar. So you can see the first reason, H2O is angular or we can say bent shape and BeF2 is linear. Okay, that is the reason. So the correct answer for this question will be option number A. Next. Okay, so equal masses of methane and hydrogen are mixed in an empty container at 25 degrees Celsius. The fraction of the total pressure exerted by hydrogen is. Okay, so first of all, methane and hydrogen we have taken equal masses. So let it be x gram and let this also be x gram. Okay, now you can calculate the number of moles of both. So number of moles of CH4 will be x by 16, that is molar mass, and here number of moles of hydrogen will be x by 2. Okay, now we can calculate the mole fraction of, we have to calculate the mole fraction of the given compound, that is hydrogen. So let us calculate the mole fraction of hydrogen. So number of moles of hydrogen by number of moles of hydrogen plus number of moles of methane. So if we calculate this one, we'll get x by 2 whole divided by x by 2 plus x by 16. Okay, so if I solve this, I'll be getting 8 by 9. Okay, now the question is asking the fraction of the total pressure, means the partial pressure of hydrogen. So if we have partial pressure of hydrogen is proportional to mole fraction of hydrogen, right? So that is 8 by 9. So the correct answer for this question will be option number B. Little tricky question but easy. Next, thermodynamics question, one of the most important formula based question. Standard enthalpy and standard entropy changes for the oxidation of ammonia at 298 Kelvin are given to us. Okay, standard gives free energy for the reaction. So we know very famous formula, delta G is equal to delta H minus T delta S. Here we have to be careful about the units. Okay, so you can see delta H is in kilojoule and delta S is in joule. So I'll convert this one also to kilojoule. So we can take delta H as minus 382, okay, 0.64 kilojoule minus temperature is 298 into delta S is minus 145, 0.145 I'll take because it is the units are in joules. So now if you solve this, we'll get minus 382.64 plus some value will come. Okay, so now you can see which can be the nearest answer. Okay, you need not solve it. So this one will somewhere around point something will be coming, subtracted from my 382. So the nearest answer will be, you can easily guess, it will be around 339. Okay, so the correct answer for this question will be option number C. Okay, next. Again we have from this is from ionic equilibrium. The heat of neutralization of strong acid and a strong base is a constant value because, okay, so this is because whenever we do this reaction, the reaction always takes place between H plus and OH minus, right? So only H plus and OH minus react in every case. So when the reactants are same, conditions are same, the value will be constant. So the correct answer for this question will be option number B. Next. Okay, we have this question is from chemical equilibrium. So we have a compound, this NH4CO NH2 decomposes to give you NH3 and CO2. If the equilibrium pressure is 3 atm, means the total pressure at equilibrium is 3 atm. For the above reaction, Kp for the reaction is, okay, so first let us write down this reaction. NH4 C double bond O NH2 gives us 2 NH3 plus CO2, right? Next we have, this is a solid and these two are gases, right? So for solid the pressure is not calculated or not considered. So this one will be, let this pressure be 2p and this pressure be p at equilibrium. So what I can say, the total pressure is how much? 3p. According to the question, the total pressure is 3 atm. 3 atm. So that means P is equal to 1 atm, right? Now what I can say, the pressure of NH3, partial pressure of NH3 is 2 into 1, that is 2 atm, and I have pressure of CO2, that is 1 atm. Okay, now calculate Kp value. Kp value is pressure of NH3 whole square into pressure of CO2. So pressure of NH3 is 2 atm, so 2 square into 1, we will get 4 atm cube. The correct answer for this question will be option number A. So little tricky question, but direct formula based this part. Here we have to find the pressure individually. Next question. Why only AS3 plus gets precipitated as AS2S3 and Zn2 plus as ZnS when H2S is passed through an acidic solution containing both AS3 plus and Zn2 plus? So what the question is saying here, we have two ions, AS3 plus and Zn2 plus. These two are reacted with H2S. Okay, so in this it was found that AS3 plus forms this precipitate, whereas ZnS is not formed. Okay, what can be the reason for this? So this is very direct question. What is the condition for precipitation? The solubility product should be less. Okay, so solubility product of AS2S3 is less than that of ZnS. Okay, because the solubility product is less, it undergoes precipitation. So the correct answer for this question will be option number A. Next. Which of the following species do not show disproportionation reaction? Okay. What is the meaning of disproportionation reaction? When the same element undergoes both oxidation and reduction. Okay, the same element should undergo oxidation and reduction, then that is called as a disproportionation reaction. Now let us check the oxidation state of chlorine in all the options. So in first one, if you say X minus 2 is equal to minus 1, so I can say chlorine is in plus 1 oxidation state here. Now coming to second option, X minus 4 is equal to minus 1, so X is equal to plus 3. Here chlorine is in plus 3 oxidation state. Now X here in option 6, it is minus 1, so X is equal to plus 5. So chlorine is in plus 5 oxidation state. Now coming this one, x minus 8 is equal to minus 1, that is x is equal to plus 7. So chlorine is in plus 7 oxidation state. Now what is the electronic configuration of chlorine? That is, I am writing just the outer configuration, 3s2 3p5, right? So it can show an oxidation state of plus 2 plus 5, and the maximum oxidation state that can be shown is plus 7, right, when all these electrons are left. So when an element is already in the highest oxidation state, it has the only chance to get reduced, right? It cannot get further oxidized. So this last option, chlorine, this one cannot be further oxidized, it has only option to get reduced. But we know disproportionation reaction means it should go both oxidation and reduction. So this chlorine cannot go further oxidation. That is why this element or this molecule cannot show disproportionation reaction. The correct answer for this question will be option number D. Okay. Next question. Which one of the following sets of ions represent the collection of isoelectronic species? Very simple one. Same number of electrons should be there. So we see potassium, chlorine, magnesium and scandium 3+. So potassium, if you take 19, 1 electron is 18, chlorine is again 18, magnesium 12, so it is 10, right? So this is not isoelectronic. Next, sodium is 11 plus 1 means 10, calcium is having 20, that means it is 18, so this one is also not isoelectronic. Now this one is potassium 19 plus 1 means 18, then we have calcium is 20, plus 2 means 2 electrons will be removed, again 18. Scandium is 21 and if you remove 2 electrons, 18. Chlorine is 17 and you add 1 electron, that means it is also 18. So in option C, all the ions are having 18 electrons and they are isoelectronic species. So the correct answer will be option number C. Okay, next. Which of the following ions has the highest value of ionic radius? Okay, so we have two things for ionic radius, you should know. The negative charge, if the negative charge is more, okay, then size will increase, and if the positive charge is more, then size will decrease, right? So first of all, all those ions which are having positive charge, they will be smaller in size, so we can eliminate these two. For more size, we need negative charges ions. So you see oxygen is having 2 minus, F is minus 1. So more is the negative charge, more is the size. So definitely A will have the largest ionic radius. So correct answer will be option number A. Okay. Next. Acidified sodium fusion extract on addition of ferric chloride solution gives blood red coloration which confirms the presence of. So this is your some basic principles of organic chemistry. You should know this reaction is used for the detection of nitrogen and sulfur. So correct answer is option number A. Next, which of the following is least stable? So carbocation stable, one very important topic of GOC. Okay, so what is the order of stability? 3 degree, then 2 degree and then 1 degree. Okay, so if you see the first option, this is a primary carbocation, this is secondary, this is tertiary, and this is also secondary, right? So tertiary will be more stable. Okay, so that is why the correct answer for this will be option number C. Okay. Next, IUPAC name of the compound. So first of all, give the priority groups. So we know acidic group is having more priority. So this is 1, 2, 3, then we have 4 and then 5, right? So now on the fourth carbon we have a substituent, that is your OH group. The name of this substituent is hydroxy group. So 4-hydroxy you can find in option number B and option number D. We can eliminate A and C. Now this, so 4-hydroxy we have 5 carbons spent, 3 on the third position we have double bond, so 3 oic acid. Here 4-hydroxy, 4-methyl. So at the 4th position there is no methyl group. This is a part of the main chain. So this option is also incorrect. The correct answer for this question will be option number B. So this is also important topic from GOC. Nomenclature, all the functional groups, how to name them, please practice it. Next question. The order of reactivity of halogen in aliphatic substitution reaction. Important one. Here the order of reactivity, please note it down, depends on electronegativity. Okay. So if we see the values that are given, we know fluorine is more electronegative than chlorine, then bromine. So the order will be fluorine greater than chlorine and then bromine. Okay. So the correct answer will be option number C. Next, a plot of one. So we have come to kinetics, okay, most important topic, high weightage topic. So a plot of 1 by T versus ln K for a reaction gives the slope of this one. The energy of activation is how much? So first of all, this question is from your Arrhenius equation, that is K equal to A into e to the power of minus Ea by RT. Taking ln on both sides, what will get? Ln K is equal to ln A minus Ea by R, okay, into 1 by T. Now the plot is versus ln K versus 1 by T. So what is the slope of this graph? Slope is minus Ea by R, which is equal to, according to the question, the slope is given to us minus 1 into 10 to the power of 4. So I can write this equation like this: minus Ea by R is equal to minus 1 into 10 to the power of 4. Negative we can cancel. So what I'll get? Ea is equal to R into 10 to the power of 4. So R value is 8.314 into 10 to the power of 4. So that is 83140. Now you see the options are not matching, but this one can be written as 83.14 kilojoules, right? So the correct answer for this one will be option number B. Okay. Even after finding the answer, your little rearrangement is required to get the correct option. Easy one, application based question. Okay, next. Again from kinetics, which is the wrong statement. Okay. Rate constant is equal K is equal to Arrhenius constant if Ea is equal to 0. I think this statement is correct. You can see K equal to A into 1 by e to the power of Ea by RT. If this activation energy becomes 0, then I can say this whole part will become 1 and K will be equal to A. So this statement is correct. They are asking about the incorrect statement. Now ln K versus 1 by T plot is a straight line. Just now we discussed the slope is minus Ea by R. So it is a straight line. This statement is also correct. Next we have e to the power of minus Ea by RT give the fraction of reactant molecules that are activated at the given temperature. This is also correct. In this equation, this part Ea by RT, okay, it represents the number of molecules that are having energy higher than the threshold energy. So this statement is also correct. Next statement we have presence of catalyst will not alter the value of Ea. So this is the incorrect statement. The catalyst fastens the reaction or increases the rate of reaction only by changing the activation energy. Okay. So therefore presence of catalyst will definitely alter the Ea. This statement is incorrect. So the correct answer for this question will be option number D. You have to find the wrong statement. Okay. Next question. In a hydrogen oxygen fuel cell, combustion of hydrogen occurs too. Okay. So to generate heat, no. Remove absorbed energy from electrode surface, there is nothing like this reaction happening there. Produce high purifying water, no. It creates a potential difference between the two electrodes. Yes, this is correct. Because of this combustion, there is a potential difference generated. So correct answer for this question will be option number D. Okay. Easy one, theory based question from electrochemistry. Next. Okay. Solutions chapter, a very high weightage topic. Please prepare this topic thoroughly. All the examples, all the graph, all the formulas are very, very important. Next. A mixture of two completely miscible non-ideal liquids which distills as such without change in its composition at a constant temperature like a pure liquid. So we know this is nothing but your azeotropic mixture. So what is azeotropic mixture? They have a constant boiling point, okay, and as because of this they cannot be distillated or cannot be separated through distillation, right? So the correct answer will be azeotropic mixture. Next question. Okay, again solutions chapter. The osmotic pressure of 6.84% mass by solution of cane sugar at 300 Kelvin, the molecular weight is. So we have to find out osmotic pressure. See, we all know the formula for osmotic pressure, pi is equal to CRT. But what is important here is this 6.84%. What does it mean? And it is given mass by volume. What does that mean? See here, very, very important topic or point, mass by volume. This means 6.84 gram of sugar, okay, in, we have 100 ml of solution. This point, if you understand, this question is very easy. So what I am saying, the volume of the solution is 100 ml, mass of the solute is 6.84 gram. Now can we calculate the osmotic pressure? We have this formula, pi is equal to C into R into T. C is what? Given molarity, that is given mass by molar mass. Given mass is 6.84, molar mass is 342 into 1000. Okay, volume is 100 ml. Then R is 8.31, sorry, R you have to take 0.0821. Okay, this one 0.0821. Temperature is 300 Kelvin. So you can just solve this calculation. If you solve it, the answer for this question will be option number B. Okay, 4.926 atm. Okay, next. The boiling point of benzene is given 353.3 Kelvin when 1.80 gram of a non-volatile, non-volume solute was dissolved in 90 gram of benzene. The boiling point is raised to 354.1 Kelvin. Kb value is given to you. Then the molar mass of the solute. This question is from your elevation in boiling point, right? So what is the formula? Let us collect the data first. What is the actual boiling point of benzene? 353.3 Kelvin, first of all. Then what is the mass of the solute? Mass of the solute was added is 1.8 gram. Then what is the mass of the solvent? Mass of the solvent is 90 gram. Okay. Next, what is the final boiling point? 354.1 Kelvin. Then what is the Kb value given for this one? 2.52 Kelvin kilogram mole inverse. The molar mass of the solute is asked. So now first we can put all this data to the question. Tb minus T naught B is equal to Kb into, for molality, given mass by molar mass into 1000 by mass of the solvent, right? So like we can put all this data. Tb value is 354.1. Then T naught B is 353.3. Kb value is 2.52. Okay. Then W2 is, what is the mass of solute? 1.8. Molar mass we have to find out into 1000 by mass of the solvent is 90. So we have to solve this equation and find the value of M. So calculation in this question is little lengthy. Okay, so there will be certain questions which will have lengthy calculations. So you have to manage time. The questions which are very easy, some time from you have to save from there, and you have to dedicate to this. And you can also see the answers are not very nearby, options are far away. So we can easily do small little calculation and guess the answer. Okay, so if you solve this one, the answer you'll be getting will be around 63 gram per mole. Okay, so the correct answer for this question will be option number D. Okay, so please check the calculation. If you have any doubt in this question, please let me know, okay, in the comment section. Next question. Okay, next question is again from electrochemistry, one of the another high weightage chapter. We have been given with a reaction. E naught of the cell is given. Calculate the equilibrium constant. I have told you also when I discussed this chapter videos, electrochemistry, this equilibrium constant formula is very, very important, right? So we have this formula, E naught of the cell is equal to 0.059 by n log of K. Now this 0.059 you can consider is at 0.06 for easy calculation, and in this reaction if you see n value will be 2. So E naught cell value is 0.46 and I can write this one as 0.06 by 2 log of K. Now this one if I get, it will be 0.03. here it is 0.46 by 0.03 is equal to log K. So we know 15 3 is 45. So this value will be coming around something 15 point something equal to log of K. Right. Now if you say, I can write K is equal to 10 to the power of 15 point any value, let it be X. So now what will be the value? If you see, it will be 10 to the power of 15 into 10 to the power of X. So now you can see the options. There is only one option where the 10 to the power of 15 is there. Okay, you need not solve this part. So there is only one option with 10 to the power of 15. So the correct answer for this question will be option number C. Okay. Easy question. Equilibrium constant formula is very important. So very easy numericals are asked from this topic. Next question. Okay, again this one is from Kohlrausch's law. We have the molar conductivities at limiting molar conductivities for NaCl, HCl and NaAC. So let us first write down this data. NaCl, HCl and NaAC. So this value is 126.4. This value is 425.9 and this value is 91.0. You have to calculate for HAC. Okay. So now first of all, from which of the three compounds we will get H value? H value can be given from HCl, right? So first take that one, we'll add 425.9. Then we need AC value. AC value will be coming from NaAC. So that is your plus 91. Now when you take these two values, one additional NaCl is formed, that has to be subtracted. So that will be minus 126.4. So if you solve, do the addition part, very simple addition, the value you will be getting will be around 390.5. So the correct answer for this question will be option number C. Okay, next. Which of the following will not displace hydrogen? So this is like little theory based question. You should remember mercury reduction lies after hydrogen in the electrochemical series. So this one cannot replace the hydrogen. So the correct answer for this question will be option number D. Okay, next. What is the order of the reaction which has a rate law given? So order is nothing but the sum of the powers of the concentration terms. So we have to add 3 by 2 minus 1. So that will be 1 by 2, right? So the order of the reaction is 1 by 2. Very simple one. Correct answer will be option D. Next. The following data are obtained during the first order thermal decomposition. Okay, this is the reaction given. So you started with A at time 0, the pressure was 0.5. Okay, after 100 seconds, the reaction has completed, extended for some time, and at this the pressure we got is 0.512 atm. So what we have to calculate, you have to tell the value of rate constant. So we have to find the value of rate constant. So little lengthy question this one. So let us see how to solve this one. We have A giving you B plus C, initially 0.5. So when there was no reaction started, B and C concentrations will be 0 because we have just started the reaction. Now after certain time the reaction has started, let X amount of A has reacted. So what will be the value of, so this is at time equal to 0, and when time is equal to 100 seconds, X amount of A has reacted. So the concentration of A will be 0.5 minus X. So how much A has decomposed, same amount of B and C will form. So the amount of B will be X, amount of C will be X. Now according to the question, the total pressure at 100 seconds is 0.512. So we can tell P total at 100 seconds is the addition of this all pressure, that is 0.5 minus X plus X plus X. So that is 0.5 plus X. According to the question, 0.5 plus X is equal to 0.512. So what will be X value here? That will be 0.012. So now this is the value of X, the amount of A that has reacted. So at t equal to 100 seconds, what is the amount of A left? That is 0.5 minus 0.012. Okay. So now if you solve, we can take this first order, it is already, thermal decomposition is a first order reaction. So we can tell the value K equal to 2.303 by T. Time is 100 seconds. log of initial concentration is 0.5 and the final concentration is 0.5 minus 0.012. Okay, so you have to just calculate this value and get the value of K. So if you calculate it, the correct answer will be 2.3 into 10 to the power of minus 4 second inverse. Okay, even how can you identify it is a first order? You can see the rate constant units are second inverse. All the options are having second inverse, and we know for first order the K unit is second inverse. So from that also we can get that it is a first order reaction, or else if you remember, thermal decomposition sometimes also takes place first order reaction. So the correct answer for this question will be option A. Next question, again from kinetics. The time required to decompose SO2 Cl2 to half of its initial concentration is 60 minutes. So this is the value of half life. Okay, so I can write T half is 60 minutes. Okay, the time required for completion of half concentration. Now if the decomposition is a first order reaction, the rate constant of the reaction, direct formula based question, we have T half is equal to 0.693 by K. Right, the question is asking you the value of K, so we can write 0.693 by T half. Now the units are in second inverse, so we will convert the 60 minutes to seconds. So we'll get 0.693 divided by 60 minutes, then convert it into seconds. We'll multiply this 60. So if we solve this, we'll get 1.92 into 10 to the power of minus 4. So the correct answer for this question will be option A. Okay. Now next question. When an electrolyte is dissociated in the solution, the Van 't Hoff factor is. So here two cases are there. If it is dissociation, I will always be greater than 1, and if it is association, I will be less than 1. And if there is no dissociation or association, then I is equal to 1. Okay, so these three conditions arises. So in this question, the correct answer will be option number B. Okay, yeah. So these were the first 30 questions of part of the mock test 6. So please solve the questions, and if you have any doubt in any question, please comment it. I'll be addressing it in my next video. And if you have found this video useful, please like, share and subscribe the channel. Don't forget to join the WhatsApp channel for all the updates, for all the solutions. Thank you.